For us to be successful in the next part of this lesson, we have to review prime factorization. My hope is that I have gone through this with you, but if you guys are ahead of me in terms of where we're at with our computation review stuff, you may be needing to review this independently. So we're just going to review it in this lesson. So prime factorization is breaking a number down into all of its primes. So one concept is to do a factor tree, which is the method that I prefer. You can also use the division method. To me, the division method is when you write out 81 and you only divide by primes out here. I'm not a super fan of that one just because if somebody is not careful, sometimes they divide by a non-prime number. So what are prime numbers? Prime numbers are those numbers that cannot be broken down any further. Examples would be 2. 2 can't be broken down any further. 3, it can't be divided out any further other than having 3 in itself as factors. So those would be prime numbers. 4, for example, is not prime. That's what you would call composite. It's composed of other numbers because 4 could be broken down into 2 times 2, okay? You could also do 4 times 1. So once they have more than one factor, they're no longer considered prime numbers. So we're going to go ahead and break this down as far as we possibly can. So I'm going to use the factor tree method. So this method, as you're working through it, if you break it down differently than I do, we're still going to end up with the same answer in the very end as long as we both did our math correctly. So when I think of 81, well, what number times a number gives me 81? 9 times 9 is the one that pops into my head. I may have somebody else. I'm going to show that no matter what I do, I'm going to get the same answer either way. Maybe somebody else said 27 times 3. Probably not super likely that somebody does that, but they may, okay? So now I'm going to continue to break down each level of this tree until I can't break it down any further. And when I can't break it down, I'm going to circle that number. So here, 9, I could still break down because 9 is the same as 3 times 3. Okay, so I can break down this 9, 3 times 3. Now, can I break 3 down any further? No. The only way I can get 3 is 3 times 1. So this is a prime number. So my prime factorization is finished on this one. Okay, I've got 3 to the power of 4 would be the prime factorization of 81, or I could write it out as 3 times 3 times 3 times 3. We're going to be leaving it in this concept for the activity that we're going to do next in this lesson. Okay, so now if I continue just on the other way that I had broken this down, this 3, it can't be broken down any further, so I'm going to circle it. And for 27, that would be 3 times 9. Okay, that 3 can't be broken down any further, and 9 is 3 times 3. Take note that I ended up with the same answer either way. I still had 4 3s. Okay, so the way that you initially break it down and how you choose to break it down by its factors is up to you. In the end, we should all end up with the same answer. So we're going to go ahead and practice this concept as a review. And for some of you, it may be initial teaching also. Okay, so let's try this one. This is a big number. And yes, you can use your calculators to help you on this. I'm not expecting you to know numbers off the top of your head. So if I'm using my calculator, what I'm going to do is I'm going to punch in 945. So 945, and I want a number that will go into that. Well, it ends in a 5, so I know that 5 is going to go into that. So I'm going to use 5 as one of my numbers. But I need to figure out what I'd have to take 5 times. So I'm going to punch in 945 and divide that by 5. And that gives me 189. Okay, so I have 189 there. Now, can 5 be broken down any further? No. I can only do 5 times 1 to do that. Okay, so for 189, if I want to break that down, I know it looks like a weird number. One concept is you can go through and check some of the rules. Well, one rule is if a number can be divided by 9, for example, is if the sum of these can be divided by 9. So 9 plus 8 plus 1 gives me 18. 9 would go into that. So I'm going to try 9. Not try it. I know 9 will go into it. So I'm going to take 189, which is still on my calculator, and hit divide by 9. When I do that, I get 21. The key thing on this, you can never have a decimal number. Once you hit a decimal number in there, you've done something wrong because that means that that number can't be broken down by that. Prime factors are going to be whole numbers that will go into that number. So now if I break this down, 9 would be 3 times 3. Okay, 3 can't be broken down any further, so I'm done. 21 would break down to 3 times 7. Okay, these are the lowest number. Those are prime numbers. So my prime factorization is 3 times 3 times 3 times 5 times 7. So there's my prime factorization. Another method that this may be written out, maybe if you're doing standardized testing, would be 3 to the third power times 5 times 7. Now with the activity that we're going to be doing later in this lesson, we want to leave it in that format because it's going to help us to be able to break into pairs or partners. Okay, so let's go ahead and try another one here. That one was a pretty big number. I promise we'll do some easier ones. Okay, so 234. So ends in an even number, so that means 2 will go into it. So we're going to practice this concept. So if I punch in 234 divided by 2, because I'm going to use 2 to start out with. 2 is prime, so I'm going to circle it. And when I divide that by 2, it gives me 117. Okay, so 117, once again, kind of a tricky number. So when I look at this, rules that I check, does it end in 2 or end in an even number? No. Does it end in a 0 or a 5? No, because that would tell me that 5 would go into it. So then I tend to jump to my next rules would be if I add the digits together, so 1 plus 1 plus 7, either and 9 or 3 will go into those, then I could divide by 9 or 3. So let's see, 7 plus 1 is 9. So I know that 9 will go into it. Okay, so I'm going to hit 117 divided by 9, and that gives me 13. 9 can be broken down into 3 times 3. 13 can't be broken down, so we're done. Okay, so my prime factorization would be 2 times 3 times 3 times 13. Or another method would be to write it out as 2 times 3 squared times 13. But once again, for today's lesson, we're going to leave it in that top format. Okay, because we're going to be doing another step from that. Okay, so I'm going to slide one out here that I want you to try. Okay, so go ahead and break this one down. Okay, 125, break it down into its prime numbers. And then when you're finished, start your video back up. Okay, so this was working. When we broke it down, we ended up with 5 to the third power, or 5 times 5 times 5 was 125, broken down into its primes. Okay,